Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, and in this session, I'd like to show you some of the major uses of HSS and also how easy it is to actually use. The HSS module is a surface machining module for smooth and powerful machining of localized surface areas in the part, including undercuts. It provides easy selection of the surfaces to be machined with no need to define the boundaries. It supports both standard and shape tools. What I'd first like to do is machine this wall over here, and you'll note there's also a slot going here. And what I'd like to do is I would like to actually have the minimum amount of cuts needed on the face itself, and also I would like to jump directly from this face to this face as if it was one straight face without having to block up this space over here. So I'll start my HSS operation. As we see here, HSS provides 9 different toolpath definition strategies that enable the user to work differently on each area as needed. The linking moves between the toolpaths can be controlled by the user to avoid holes and slots without the need to modify the model surface. And in this particular case, I'll choose the option of parallel cuts with constant Z. My geometry in this particular case will be this wall and this wall only. And the tool that I will be using will be a 10mm ball and mill. And when I go to my toolpath parameters, I'll put in a maximum step over of, say, every 2 millimeters, and I'll be going zigzag. Now, before I do anything else, let's do just a quick save and calculate of the part itself, and let's do a simulation. As you note, the toolpath itself, when it gets to this slot, it simply goes up, and then when it gets to the edges, it also goes up. The way we deal with that is with 2 simple moves. I'll simply go into my link area, and I'll use the option with gaps along cut. The first thing I'll do over there is I want it to have it go directly to the next area, and in between slices I want to have it blend with the spline itself. And I'll also use my entry using a lead in and also use a lead out. My lead in and lead out will be a tangential arc. If I do save and calculate now, and we take a look at our toolpath in our simulation, you'll note that we have the lead in and the lead out at the very bottom, and also it's using the minimum amount of space needed to do its toolpath and going directly over this slot as if it was one straight surface. Next, I'd also like to machine this floor over here using HSS. And we'll also note that there are holes on the bottom of this floor as well. So again, we'll start another HSS operation. And this time, we'll use the option of parallel cuts constant Z, and we'll change that to linear, working with linear motions on that floor itself. The geometry, as I said, will be this floor over here. The tool that I will be using will be an 8mm ball and mill, and my toolpath parameters, I'll have that at every 2 millimeters, and my sorting will be at zigzag. Now if I go into my link, I'll do exactly what I did before. With my gaps for those holes in the bottom, I'll have that go directly, and also for my slices, I'll also have that as direct. When I go to my lead in and lead out, this time I'll be using a different type of approach. Instead of a tangential arc approach, I'll use a vertical tangent arc. In other words, going in from the top, and the same thing as I lead out of my part itself. If I do save and calculate, and we take a look now at our toolpath, you'll see it goes exactly across that part, curving in, curving out on the part without any problem, and this is done in a few easy steps. Next, I'd like to work on this curve over here, on this surface over here, and this one over here as well. and this one over here as well. So I'll start my HSS operation, and I'll choose in my HSS the option of morphed between curves. Now my first surfaces, I'll choose my surfaces, and I'll choose this surface, the next surface, and the third surface. My starting edge, I'll choose that as the top edges of the part itself, and we'll choose that edge, this one, and the third one over here. That's my top edge. My end edge will be the ones on the very bottom. 1, 2, and 3, and accept that. The tool that I'll be using will be my 8mm ball and mill, and I'll choose that from my list. My toolpath parameters, I'll be going maximum step over of every 1mm, and my sorting will be again zigzag. Now if I go into my link area, I'll just leave it right now the way it is, but I'll just go into my lead in and my lead out, and I'll have my default lead in and lead out as a vertical tangent. And one more thing, in my links, I'll have my gap, my slices also as direct. Now just say save and calculate, and we'll take a look at our simulation, and you'll see that the toolpath goes directly on that surface exactly the way I want to have it going in and going out. But now let's point out one more thing. You'll note that we have these walls over here, and this, by the way, one of the strong points of HSS. We have this wall over here, and we have this wall over here. I'd like to make sure that my tool does not touch any of those walls. I want to actually have it go further away from those walls. The way we deal with that is with a gouge check. So I'll choose my option gouge check, and I'll open up the possibility of actually having a gouge check. I want to have just my check surfaces. The check surfaces are the surfaces I don't want to touch, the ones I want to keep away from, and I'll choose this surface over here and that surface over there. Now in this field, the stock to leave, I'll say how far away do I want to actually keep it from that wall, and I'll just say that so we can see it actually. It's keep away by 10mm, and let's just do a quick save and calculate without dealing with any of the strategies of how do I want to retract from that surface. If we take a look at our tool path that we have from a simulation, you'll see that it stays away from that wall and it actually jumps up at this point to the very top, and the same thing on the other side as well. I like to change the strategy so it actually stops at this area and just goes back and forth. So I'll go back into my strategy over here, and we'll choose the option of leaving out gouging points and then trimming them at those collision points. Now when I do save and calculate, and we'll simulate our toolpath, you'll see that the toolpath goes exactly to that point and just simply goes back and forth on that surface. Now another option I'd like to show in HSS is how we deal with undercuts. If we take a look at this surface over here, this surface is actually undercut from this area over here. So the way we'll do that, we'll be using a T-cutter or a woodruff cutter to go into that area. We'll simply start a new operation, and again I'll use HSS. The geometry that I will be using will be this surface over there. What I'd like to do though is I like to keep the tool away from this surface though. I can do either a gouge check as I've done before, or I can actually also use the option of extend and trim. By simply going into here, I can simply say let's trim it, and I'll give it a negative value, let's say 12mm, and the end of it also do the exact same thing, give it just a simple negative value of 12mm. The tool that I will be using will be a slot mill. of 30 millimeters, and my toolpath parameters, I'll leave that at 1 millimeter, with my sorting going zigzag back and forth. In my link area, I use my large gaps as direct, and the same thing with the links between the slices themselves. I'll use a lead in and a lead out, and this time when I use my lead in and lead out, I'll be using a reverse tangent because I want the tool to come in reverse into that area rather than come around, as to avoid these walls over there. Let's do a simple save and calculate, and in our simulation you'll see, if we use our wireframe, you'll see that our toolpath is going exactly on those walls itself, plus the approach is a reverse tangent, and my retreat is also a reverse tangent. If we take a look at our solid verify, we'll see, and let's first do our front view, we'll see that the tool actually does go in and mills out every single one of those surfaces without going into the wall, and the same thing when it goes down to this area as well. If we take a look at a side view of this part, and I'll zoom in over here, we'll see that the tool goes down and does an undercut on these surfaces over here, not touching any of these areas, actually machining every single area that had to be machined. The last thing I'd like to show you now is the perfect way to work on these fillets on the part. And I'll just be working right now just on these fillets over here. I'll simply start a new HSS operation, and I'll use the option of morph between curves. My geometry in this particular case will be these surfaces over here, around the part over here, and I'll just stop at that point itself. My start edge, I'll choose my top edges of those areas over there, such as this one, all the way around the top of the fillet, and my end curve will be obviously on the other side as well, choosing my bottom edge of those areas itself as we go around the part, and we'll end it off over there. The tool that I will be using will be a 6mm ball end mill, and I'll create my 6mm ball end mill. The toolpath parameters, I'll have that at maximum step over. For this case, I'll use 0.2 millimeters, and sorting going back and forth. Now in my link area, I'll use my lead in and my lead out. My gaps along cuts, I'll leave that exactly the way it is. My link between slices, I'll have that as blend splined. Now when I do save and calculate, and we take a look at the toolpath that we've created, you'll see that we'll have a toolpath exactly on the fillet itself, and this is going to be covering, because of the way I did it, every single part of that surface. There's no part of that surface left out. There's no need to extend the toolpath or make it shorter. Every single one of those parts of the surface has been filled. And if we also take a look at the edges, you'll see exactly how it's blended from one splice to the next with our lead in and our lead out. This is the most perfect way to do any type of fillet of this sort. We've seen in this demonstration on HSS some of the major advantages of using HSS on parts, whether it be for undercuts, for fillets around the part, or even on radiuses, or even flat floors or walls. It's a simple tool that can be used on any part, whether it be a 3D part or 2.5D part. You don't even have to be doing any kind of 3D machining. This is a perfect tool to get to any of those surfaces where you could not get to before, and it's done easily with a really nice, smooth toolpath. The HSS module is an important addition to the integrated SolidCAM and SolidWorks solution, and is essential for each manufacturing facility as an excellent complementary module for the machining of all types of parts. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.